Good evening to our hosts from New Zealand, and good morning to all the participants from India. We have a very interesting topic today, which is delivering solutions on the web, full stack web application development. This talk will be taken by eminent professor, Dr. Stuart Charters, who does research on the human aspects of computing, including software engineering, visualization, and e-research. Dr. Stuart is the director, Signal ICT Graduate School, which focuses on growing and developing technical professionals of New Zealand. We welcome you, Dr. Stuart.
Thank you, and thank you for having me this morning for this talk. I'd like to spend the next 30 minutes or so talking to you about full stack web applications and looking at that from both a organizational side, but also looking into some of the technical aspects of that. So to start off with, just highlighting why this is a topic that I think is so interesting. Historically, we've developed applications in what I might call the traditional sense, applications that run on individuals' computers, and for organizations developing software have run purely within the boundaries of their organizations. Moving to web apps changes that completely. And on my next slides, we'll just see visually some of those differences. The other reason that I think this is so interesting is that it changes what the computer in front of a person needs to run if web apps become the default and the norm. We move away from heavyweight operating systems and computers that can do lots of things to computers that just need to run a web browser as a portal into all of the applications. And that really changes some of the dynamics around what end user computing devices are and what they need to do and the capabilities that they need to provide, and for organizations about how they need to be managed. The other things that I think is really interesting about web applications are the issues of security and scalability. In moving applications outside of organizational boundaries, that produces a larger attack surface, if you will, that these applications can be attacked from because they're on the internet, which changes the security requirements and the security models that we need to use. But going back to that browser as the portal, it also changes the security dynamics within an organization, because they no longer need to worry about running all of the applications within their organization and having a broad attack surface across all of those different servers and applications. And they now change the attack surface or the security concerns that they need to worry about much more to protecting their end users and the end users' devices. But let's start off by looking at that traditional versus web apps issue. On the left-hand side here, I've got the traditional model, where we have this white box around here being an organizational boundary. So think of this as a bank, a university, a large corporation, and they're within their organization running all of the applications that they need to service what their customers and their users require. And we have what is a common model for these applications, a multi-tier application where something is running on the client, on the desktop computer, and something running on the server. And so we get the client server model running. Sometimes there's multiple servers involved, and we get 3-tier architectures that you may be familiar with. But fundamentally, everything is within the organization. And the way that organizations have focused on their systems and protecting things is making sure that this box around the edge here is really, really secure. On the other side of my screen, we see what the web architecture looks like. So we still have this idea of the client, but now that's the only thing within the organizational boundary. We have the cloud being representative of the internet, and then within inside another box, we have the web app provider, their solution, which will again consist of multiple tiers that need to be provisioned to deliver the solution. So we've changed the paradigm around how and where we're delivering information, where we're storing information, and who is responsible for maintaining these different boxes. So let's go and look in a little bit more detail at what the architecture of these web apps is like, and then as we go through, we'll go down into a little bit more technical detail before coming back up to look at some of the issues and things that we need to think about with web applications, certainly in terms of security and scalability. So we have a client here, but this is a web browser. We have a connection typically over the internet, and we have a web server which is running application code. Now, you may have heard of microservice architectures, and so in this application layer, we may have this made of multiple little services, and they may be spread across multiple different web servers, or it may be a single piece of code. Behind that is typically some form of data store. And so you can see that these layers are very similar to what we might have in a traditional application, at least in terms of having multiple layers, but the detail of them can be quite different, particularly in that application layer, where we see that traditionally our applications will have been written in one programming language and on one architectural platform. They may all run on Windows servers, they may all run on Linux or some other environment. When we move into the web application environment, we may have these groups of microservices, each of which are written in a different programming language, running on different servers with different operating systems, different operating models, and potentially different organizations responsible for looking after and maintaining them. So we move both in human scale away from a group of people, a small group of people potentially being responsible for an application, to multiple organizations and multiple groups of people being responsible for delivering an application on the web. The other thing that tends to change is that within a traditional organization and their applications, we know who our users are. We know that they are people within our organization, and we can control what software they're running, what their devices are using, or we're installing monolithic applications that are solely running on the user's computer. With a web application, we're expecting now hundreds, potentially thousands, potentially millions of these clients to be connecting. And within our organization, perhaps those clients were expected to only operate during business hours within the country, or if we're servicing a region, we understand what the time zones across that region are and how our work patterns change. With moving up to web applications, we now have people being able to connect at any time of our day and night from anywhere in the globe. So suddenly the reliability of our system becomes really important, and potentially having 24/7 uptime with no time to schedule downtime or to drive organizational behavior around the needs of our application can change. And often with a web application, we're now building those applications not to service one client, but to service many clients. So we have a number of key considerations that we need to think about when we're developing these web applications. The first one is the user interface and user experience. And this has become really, really important for web applications. It used to be with the development of traditional applications that we could train our users in how to use them, and that they may have been required to use them as part of a business process, and we could invest time in training and developing them. Now, organizations are adopting multiple web applications. Often these web applications are also being made available to individual customers and small and medium enterprises, where similar systems were previously available to large corporate organizations. To get that last mass level of adoption, you can't afford to require people to have training, because there may simply not be people who are able to deliver that training in all the localities that you want the app to be adopted, and it's also a barrier to adoption. So starting with the iPhone, which was, you know, a good decade and a half ago now, we saw the need for user interfaces to meet user needs, and rather than users adapting to user interfaces, to become really important. So a lot of web applications need to invest a lot of time and energy in developing good user interfaces with a good user experience, so that relatively novice users and potentially people who use the applications infrequently can rapidly get up to speed and use the applications, and especially after time away from the application. As part of that, understanding the navigation structure of the system and providing really good searchability becomes important. Just to take an e-commerce example, because many of us are familiar with Alibaba and Amazon and the other large e-commerce stores, if they didn't have good search capability, it would be extremely difficult to find things in which we were interested. So it's not just enough for them to have well-structured categories that things are in. We need to have search as our first order ability to find information. And along with those user interface and user experience aspects, also comes some back-end issues that we need to be really aware of. And these two do interact with each other. So speed and performance become really important. And that is, as well as optimizing how well things on your server work, it's also understanding the geographic distribution of your users so that you can provide your scalability to reach them close to their market. And in internet terms, you'll often hear last mile being talked about, often the user's mobile phone connection to the internet, or their home broadband, or even dial-up connection. We need to be really mindful of the performance of our end users and what that last mile connection is. As an organization, we might have really good connectivity to the internet, but if our end users have poor connectivity, then optimizing our user experience to be something that works with relatively poor connectivity is really important, because the perception that people have of our application isn't all in our control. A large part of it is down to that last mile connection and how it performs on their local browser. So with that then becomes the issues of scalability and security. This is both scaling geographically. If we think about large movie providers like Netflix, it's no good them hosting all of their content on one central set of servers, because the latency to get that to people in continents that are not the same as those central servers is too high. And even within a country or a region, people like Netflix push their content out onto edge servers to optimize the performance of their system for that last mile. That also reduces the load on their central servers and also reduces a dependence on those servers. So if they have a systems failure, they don't have a single point of failure, they have multiple backups and alternate delivery routes that they can make use of. With all of that, of course, security becomes really important, and that's made particularly difficult because we don't control the whole environment. We control the environment that we have around potentially our web application, but of course, with cloud providers, we may not own all of that security arrangement, all of that security layer, and as part of that, we don't certainly control the user's device and their browser. So we've got lots of different considerations to bring in, and not that these were never considerations for the development of monolithic and traditional applications, because of course user experience and user interfaces were important, but the way that, and also scalability and security, but the scale and the context of these does change with web applications. So I want to talk briefly about the anatomy of a web request. So that is when we have somebody on our web application from their client browser, here, what is happening? Now we've got these arrows that run between the different aspects. But really what is happening when a user clicks on a link or submits a form is that they are sending information through from their client across the internet, our cloud shape here, to our application layer. Now, in that application layer, there is some processing that is happening. And often as part of that, then a request will be made across to find some data or to secure some data in our data layer. So this is our data layer here. We'll get that information back from our data layer and often do some more processing before sending a reply back to our browser. Now, as part of this processing here, we are generating our user interface. And this is often HTML, CSS, potentially some JavaScript that is being sent back and then is being rendered on the client device. Now, we can do some local processing on the client browser. So sometimes some things are happening here, particularly with JavaScript, being able to work locally. And one of the key considerations with web applications is what happens where. Incorporating things in JavaScript, they run locally on the user's browser and provide a high level of interactivity, so help with our user experience and our user interface. But if our user has a low-powered device that struggles to run the JavaScript or has an older browser that doesn't support the latest JavaScript standards, they may struggle to run our JavaScript and therefore have performance issues with our system and have a poor user experience. If we do everything on the application layer, then we may have high latency as we have these transactions going back and forth between the browser and the application as users do different things. We're also placing a higher load on our application server, and therefore we need to provision more resource there to cope with that level of transactions. These requests are sent through as HTTP requests, and so they're encapsulated in all of the HTTP standards and using the HTTP verbs. Traditionally, get and post are our most commonly used HTTP verbs. And thinking about security, of course, we've got HTTPS transaction layer security, TLS, being put in place to encrypt the connections back and forth. In doing that, that increases our security, but then adds an extra layer of complexity at our application layer, and it also makes one of those performance things that we might like to do in caching, both at an application layer and a client layer, a little bit more tricky, because we are having now to deal with things that we're encrypting and decrypting on the fly. So I want to move on to talk about what a technology stack for a web application may look like. And there are lots and lots of different technology stacks that you can use, and even within one web application, you may use different technology stacks, particularly if you've got a microservices framework approach. But one of the frameworks that we, or technology stacks that we use, is shown here. So for a data store layer, there are both relational and NoSQL databases that are often deployed, but MySQL is one of the leading ones there, that we can develop relational databases that store the information that our web application is using. Depending on the nature of our data will drive what we're looking for in our data store. We may be looking at object storage, for static information. We may be looking at NoSQL databases, things like Bigtable, particularly where we're wanting to do very high performance queries. Where we've got highly structured data with lots of relationships in them, then a relational database like MySQL is often deployed. And so this is our data store layer, just to relate it back to what we had. At the application layer, we're often doing two things. We're often running our business logic that is processing our information, but also generating the information that is being sent to the user's browser in terms of the user interface. There are lots of different frameworks that exist to help with this. One of them, and again, one that we use and that we're familiar with here is the Flask framework. Flask is a micro framework, so it's a very lightweight framework. Other frameworks like Django exist and are heavily used. They are more heavyweight. And with all technology decisions, it comes down to weighing up the advantages and disadvantages of using each of them. Each one will come with things that it can do well and things that it does less well. Flask is a really good framework with lots of add-ons that you can build in. So if you want to build a small and lightweight application, you can do that. But if you want to build a more robust application, you can add in other modules that help you do that. Some of the heavier weight ones come with a lot of those things by default, which means that building smaller applications have a higher overhead. Flask works with Python, the logo down here. again, you can use for any programming language pretty much to develop web applications. One of the reasons that we look to use Python is that it's a multi-purpose language. It's quick to get applications developed and prototyped. It also has broad adoption across both the sciences and research. So the skills learned using Python are transferable into general programming as well. Now, whilst it's an interpreted language rather than a compiled language, its performance is still relatively good, and it does mean that you can get things up and running and tested and round a development cycle quite quickly. In terms of delivering the user experience through an interface, then the common web technology stack, of course, is CSS, HTML, and JavaScript. To do that, and again, different frameworks exist to help you with that. One of the ones that we use, particularly around bringing through templates and styling and working with the CSS, is Bootstrap, to allow you to do things quite quickly in terms of providing common user interface aspects relatively easily. So your technology stack has to be fit for purpose, and that's why, particularly if people are developing a microservices architecture, they may choose different languages and different technology stacks for developing different aspects of an application. So you may find applications that run both a relational database and a NoSQL database for different aspects of their storage, their data store. They may have different services written in different languages, either because they're developed by different organizations, or just because those are the best languages suited for the things that those services are doing. And that's a big shift from learning one programming language and an organization mandating that language to be used throughout all of the applications that they develop, because in that case they have all of an internal technology team often, and they want to have a common skill set between that. With web applications, it's probably a broader skill set that you see coming into play, and different specialists may take on roles in different aspects of that. So often as computing people, we're very keen to see what this looks like in code. So I have on the next couple of slides just some examples of little bits of code so that you get a flavor of what a web app looks like in reality. So Flask works using Python with the concept of decorators to identify which routes that are implemented are delivered by which functions that you have written. So on this example, which is just a snippet out of our code, so it's not all of the code that is running, so some other variables and connections are defined outside of this. We're setting up here a route to update a customer in our relational database behind the scenes, and then return the caller back to a different part of our interface. You can see here our different HTTP verbs to say we want you to do here accept both GET and POST requests being sent in, and we've defined a function here called customer update. If we're being sent a POST request, as seen here in this if statement, what we want to do is actually update the information that we hold. So we're doing an extraction of information into some local variables that have been sent from data that is sent through from our web form. we are making a connection to our database, and this is being managed by another part of the code. And here, so we're just executing our SQL query. We are executing our SQL query, and then here at the end of our function, we're saying, yes, we've done that, and then we're just returning our user to a different place in our web application. This bottom half of our code says, if you've come in using a GET request, then obviously you're trying to do a different thing than send us an update to our information. So we're going to do something different. And here we are doing different things depending on if you have sent a variable set through to us or not. So if you've not sent us any information, we're going to redirect you back to the home page and say, you didn't really mean to come here, you were trying to get somewhere else on our site. Let's send you back to our home page so you can find where you need to go. But otherwise, you're looking to update a particular customer through the ID that you have given us. And here we're going to extract out from the database the details for that customer, and then go back and show you a customer form with that information in it so that you can update the information and then send it back to us in our post request, which of course will then run through this part of our function. So that's our Python code running, but we need also a end user interface to display. And what does that look like? Well, it looks like HTML. This is again a snippet out of our, or a fragment out of our HTML, just the body. But instead of just having HTML and hard coding lots of things, what we're able to do in these two parts is to programmatically include information that has been sent through into this template, so that this template then can respond to any information that we send through. Here we're just listing out the table headers, and in this bottom part we are then printing out the data that has been sent through, and we're building up here a custom URL for each result, so that we can then go through and find out more details about, in this case, more details about an order that has been placed in our system. Now, in these code fragments, we've omitted a lot of the security and error checking information, just to communicate the key aspects of what is going on and give you an idea of what this looks like technically. So as we draw to an end here, what we want to talk about, though, is security and scalability with these web applications. And firstly, I want to acknowledge that security is actually a really hard thing to do. We see large corporations, governments, and even large cloud providers in the news having security vulnerabilities, having lost customer data. So it's a constantly moving field, and it's something that is difficult. And that's where I want to make my next point, which is that often we think, we can do our own security and that will be sufficient. What we're starting to see is that even very widely used and scrutinized security toolkits still have errors and vulnerabilities in them. And that risk is magnified for things that people have built themselves and that are not widely used. Recently, the OpenSSL libraries were found to have quite a long-term bug in them that needed to be rapidly patched. We've also seen, as increased computing power comes along, that it's easier to break the encryption of various security mechanisms and security algorithms. And so organizations have had to update the TLS, transport layer security version that they mandate as a minimum. Now, within an organization, things like that become really difficult if you're operating in an environment where your browser and other applications that you're providing to people are much older. But it also highlights the fact that when we build web applications, we don't write them all from scratch. We build them out in lots and lots of different components and libraries, and that you therefore need to have visibility across the component chain that you are building, because of course your components will also use other components, and any one of those components within the framework can have vulnerabilities. With traditional applications within a secure a single organization, the view was, if we can keep the attackers out, we can build a strong wall, then our systems will be okay, and therefore the security of our individual applications is less important because we're building a really strong wall around the outside. With web applications, what we see is that actually each application security at all levels is a really big consideration. The other two aspects that I want to touch on with security is that humans are a really big aspect of security. That's both social engineering of organizations to get credentials to get inside them, but also thinking about the things that we require to do critical operations on our system. If we require certain information that is personal to an individual to do a password reset or to grant access, actually, can that information be found out through other means, and therefore somebody can impersonate someone? And also, because we're divorced from our users, and they may be home computer users, and we don't have any control over their end environment, we don't know whether their systems are compromised, and therefore through the end user system, whether our systems might try to be compromised. And that might be looking at information that we've stored on their system in terms of cookies and other information. It may be that they've cached login credentials in their system. And so you see multi-factor authentication becoming really important, two-factor authentication with mobile apps, one-time passwords, longer passwords rather than more complex, short passwords becoming important just to help reduce the attack surface for those security vulnerabilities. The other thing that I want to talk about is scalability. With web applications, potentially everybody on the internet can see your application. And when you think about the millions of people just within a single country, or billions of people worldwide that have internet access, and the billions of computers, IoT devices, and other things that are online, that becomes a really scary thought. So it also talks to the security point, in that you've got lots of people that could potentially be looking to access your system. But it also talks to the need and considerations that you have for scalability. And when we're thinking about scalability, we're thinking about all layers of our application. So often we go, oh yeah, we can scale out our web server, we can have a load balancer, and we can share those requests across multiple web servers to handle that load. But we neglect that each of those web requests is going to hit our database, and actually that our database doesn't scale as well as our web front end. And so the data store actually becomes our critical point within our web application. And that really then talks to where the data dependencies are within our system, and doing a scalability analysis to understand both which bits of our application are taking the longest time to run because they impact on performance, but also those are the bits that are most likely to become bottlenecks if we do get a large amount of web traffic. And also, if we can reduce those data dependencies, reduce the number of times we need to hit our data store, then it's much easier to scale out by replication our web application, because we can have static content that's perhaps refreshed infrequently rather than dynamically generating things off a database each time, or moving from a relational database to a NoSQL model if we need to. The other thing to bear in mind with scalability is that there's multiple ways in which we can scale a system. The first one is scaling up, which is essentially providing more resources to a virtual machine or a server delivering our application. That might be more RAM, more disk, more CPU threads or cores, versus scaling out where we will run our system in multiple locations. That might be just across multiple servers within one data center, or it might be geographically distributing our data center. And with our data dependencies, that also becomes really important in how we've organized our data. I've got on here sharding versus replication as something to be aware of. Sharding is where we can divide up our data set into, for example, the data relating to different geographies, so that we could store all of the data relating to our Indian customers in India and all our New Zealand customers in New Zealand. And we don't have to replicate the New Zealand data globally, and we don't have to replicate our Indian data globally. But if our data dependencies are such that actually when you access the data, you need to be able to run queries that are across all of our users, no matter where they are geographically, then we need to replicate our database in its entirety globally. And that gives us a very different scalability solution. The other consideration within scalability is our time to scale. How long does it take us to scale up a new web server versus a new database server? Is that something that can be done dynamically on the fly, or is it a manual process that our engineers need to be involved? And also understanding what our loads are like, our base load, our peak load, and then if our web app for some reason goes viral, what that web peak load is, where we potentially get hundreds of millions of visitors in a very short time frame. So to sum up and finish, full stack web application covers an extensive area, and there's an extensive skill set required to cover that. And many people therefore focus on different aspects of it. They may focus on back-end development or front-end development and develop deeper skill sets in that, or they may try and maintain a more general skill set across the whole stack. Scalability and security are key considerations when thinking about web applications. And the other thing that I want to leave you with is that thinking in web scale with web applications with potentials for hundreds of millions of users is very different over thinking in an organizational scale, where you've probably got a finite number of users even if that number of users is very large, you can control that more easily. So thank you for taking the time to join this lecture this morning. It's been a pleasure to talk with you.